Hello everyone, this video is a walkthrough of another project done by me, and I named this project as My Drive app. So the logic which I use here is it is a client server model which communicate through sockets. So initially this is the client homepage, this is the UI at the client side, and this is the server. The server takes requests from the client and gives response accordingly. So initially the server has a user data.bin file. It is a binary file which stores the data about the user. So that's a username, ID, and its file meta offset. You will understand about file meta offset later. Then it stores it also the user's offset is 5. That means the users are to be entered from this specific offset. Now if you try to log in without registering, it shows an error saying invalid username, and then you can register Marcus. So the user is registered now. If you try to register with the same name, it will show an error that the username already exists. So how did I handle that? Register user. I have a function called search user, and I send the username in that function. If the function returns the user ID of that specific user, that means it already exists. And if it does not exist, that means it returns -1. So if it is not -1 and it is some ID, then I return 0. That means it already exists. And then the offset at which I store the user data is user offset plus user count into 64. The user count is updated every time at the beginning of the file. It takes 4 bytes of size. Now the user can log in. It has 3 options now: file store, message store, and calendar store. File store. Let's go into file store. So file store has the properties of uploading a file, viewing list of files, downloading a file, and deleting a file. The structure followed by the file store is it has the whole file is of size 1 GB, and I divide the file into blocks of each 4 KB. So, and also there is a bit vector at the beginning which is used to check if a block is filled or not, that if the block is occupied by some data or not. If it is occupied, the bit vector is set to 1, or else it is set to 0. So at the time of insertion, the bit vector is set to 1. Each block in which the data is filled, it is set to 1, and at the same time, at the time of deletion, the bit vector is set to 0. So that way, when you delete a file, you have the space to accommodate the next file, data of next file. So when you enter the data of next file, it will search in the bit vector for empty block, and it returns the address of that block. So now the structures used are, this is the meta structure. It consists of the file name, the file size, and the next file offset, and each file has its file data offset. That points to this structure, file. So file data is of 4092 bytes, and it consists of a pointer to next file data, because if the data is more than 4092 bytes, suppose 20 MB, it needs to be stored in multiple blocks, so it will have a linked list kind of storage. So in all the stores, message store, file store, and calendar store, I'm using linked list kind of storage to store the data, so that each block will have a pointer to the next block. So let me show you the uploading. I'm uploading a file. There is a file at client side called abc.txt. The file got uploaded, and then I can upload another file, song.mp3. This is a huge file. It takes a lot of data, so it's taking a little bit of time. This is how the upload file works. It writes into the data, it writes into the file, and it sets the bit vector as the file is done. Like those blocks are occupied by the specific file. So that is the use of bit vector. That's a really huge file. And then again, you can upload pictures also. So I have another file called pic.jpg. Done. Now if you notice, if I click on view list of files, these are the list of files uploaded at my server. Now if you want to delete a file, suppose I want to delete abc.txt, the file gets deleted from the server. And now if you see list of files now, song.mp3 and just pic.jpg. how I did this was I'm using BitVector for that thing. While displaying the files, I'm checking. Wait, let me show you the function. View list of files. So on deleting, I delete the link between that file and the. So when you're deleting a file, it deletes the pointer of the previous node pointing to it and sets it to the next pointer set by this. It's like linked list deletion. And then, so this is, and download the file. So I will show an example of downloading a file. This is so at client side I had pic.jpg, right? I'm deleting it. Now I can download it again. Download a file, enter the file name pic.jpg. So now you see that our file is downloaded again. So this is about the blob store. Now let's go to message store. Message store is similar to the blob store. Here I'm taking a file of size 16 MB. So it is divided into each block size of 256, and the structures which I'm using here are global values, which stores all the users count and all categories count. And then again categories, so I will be having multiple categories within it, and each category will have multiple messages, and each message in turn will have multiple replies. So the structure is each category will have one message offset, then that message offset will point to a structure message, and then it can have multiple message offsets. It can point to many other messages, and each message will have a reply message offset, and then that will point to reply message structure, and then there can be multiple replies again. So I'll show you the execution part. I'm creating a category. It uses BitVector2 to check if the block is set or free. I'm creating a category. Let's name Python, and I'm creating another Python category named Java. So if I click on all categories, then I can select a category Python. There is no messages available at the beginning, so I'll create a message. Decorators. So that is a message created by me. Now I can enter into that message. So there are no replies available. I can reply hi, good topic. So that is a reply given by me. I can create another reply, hello. I can also delete the reply. I can create another message, hello. I can delete this message also. So this way I'm handling all the CRUD operations within this, and they are specific to each directory. See, in this directory there is nothing available as of now. So this was about the message store, and the implementation is similar to the linked list. So insertion, deletion and all stuff, it follows the linked list storage kind of thing. And then later when you delete a message, it should delete all the replies within. So delete message will call delete all replies method within. Okay, and all the bit vectors will also be set to free, set to 0. The next comes calendar store. In the calendar store, it is a 100 MB file. The structures used are, okay, I'm using a date structure. So I'll tell you what this calendar store is. In calendar store, basically you can have many categories like doctors, carpenters, mechanic, and you can appoint a serviceman for each category. So you can register a serviceman for each category, and then later a user can get into a category and appoint a person within it. Like you can appoint a serviceman on a specific day for his own purpose, like for any work or anything. So that is the use of the category store. Now here if you look at the display categories, there are no categories available as of now. So I'll create a category. Category name would be doctor. So doctor. Now if I display the categories, I have doctor available. Now I'll select the category. There are no servicemen available as of now. So basically if you want to add a service, so basically if you want to add a serviceman, you have to go back, you have to register a serviceman for a category from here. So I'll register a serviceman for a category, the category number is 1. So it will ask me for the name of the serviceman. Let me say Dr. Gupta, role cardiologist, number. So a serviceman is registered under that category. Let us register another serviceman. Surgeon, phone number. So we have 2 people registered, 2 servicemen registered for that category. And now I can go into that category, and now I see that there are 2 servicemen registered for that category with their details. Now you can check the appointments of each person. Let us select Dr. Gupta. So it says he doesn't have any appointments on any day. He's not appointed by anyone. And then Dr. Mehra has no appointments on any day. Now you can appoint a person. Suppose you want to appoint Dr. Gupta, so you have to enter the date. So here there are 3 constraints for adding the date. So a person cannot appoint a serviceman if he can only appoint only after the today. If he gives an invalid date, that's meaningless. So also a person cannot register 6 months in advance to any serviceman, and a person cannot appoint a serviceman if he is already appointed by someone else on the same day. Let us try all of them. Suppose I give an invalid date 012, it will give please enter a valid date, and then again I can appoint a person, Dr. Gupta. Now if I want to appoint on suppose today it's 25th, let us appoint him on 28th, 28/07/2016. I have appointed that person. Now if I look at the appointments of Dr. Gupta, so he is appointed by Marcus on the specific date. Let's try to appoint the same person on the same date, 28/07/2016. So it says he's already appointed by someone else on this day. And another condition is 6 months in advance, right? So let's check for that also. 6 months. Let's do 26/07/2017. He says appointments cannot be made more than 6 months in advance. And now if you see the appointments of Dr. Mehra, he is not yet appointed on any day. So this is basically the calendar store. Now how I managed to do all this? So I'm creating a category based on that is like I have the category offset, and then I can only accommodate 10 categories over here, not more than that. See, category offset, and I'm dividing each file into blocks of size 64. Okay, and then later again the structures which we use here are the date structure to get the date, current date, and then calendar categories which will hold all this, and then there are servicemen. The serviceman, it is again a linked list kind of representation. So the next serviceman offset will point to another serviceman, and so on, and each serviceman will have one appointments offset, so it will display all the appointments of that serviceman. So appointments, and again it is a linked list kind of structure. So how do I handle this? The problem is when you registering a person, that's fine, there are no CRUD operations on it. So the problem will be with the appointments of the date. So what I do is I use this function get current date, where I'm using the time function of time.h, and then I'm getting local time. So I get the present date using this function, like what is the current date. I'm storing that in the structure and I'm returning it. I'm also checking is difference less than or 6 to validate if he's making an appointment 6 months in advance or not. And then again I'm having a compare dates function to validate. So when I'm appointing a person, what I do is I appoint that person, and I also check at the same time if the date is correct or not. If the date is incorrect, it will stop, and then I appoint the person. So the problem here is the dates, like suppose I have appointed a person on 28th and it is 29th now, so that value is still stored in the file, which is wastage of memory. I can free that value, I can free that space in the file. So what I do is, on every insertion I update the whole list again. So when I'm inserting again, when I'm appointing a serviceman, so I'm deleting the whole thing first. See, delete appointment. I'm comparing the dates and I'm deleting all the appointment of that person. Like if that appointment date is past the present date, I'm deleting that appointment. So I'm deleting that node in the linked list. I hope you got it. So this is the implementation of my whole project. Let me show you another features. Like that was for Marcus. I want to register another one like Tom. So Tom can log in his file store. There's nothing in his file, so every individual user has his own space. And then messaging app, this can be accessed by each and every person. See, these are the categories created by that person, Marcus. So I can select a category, enter the Python. He can create a message of his own. Hi Tom. I can select the message, I can go into Marcus. So I can create a reply over here also. Hello Marcus. So it comes with his message along with time and timestamp. And then comes the calendar store. See, even this is accessible by everyone. Doctor, I have these things. Now view appointments. Dr. Gupta. Now let's appoint Dr. Mehra. 28. We can appoint on the same date but another serviceman. So view appointment by Dom. So that is the execution of my whole project. It was a crisp walkthrough, as the code is too huge. I just briefly explained the outer layers of it. I hope you liked it. So if you got any queries, please enter them, please comment in the comment section below. And thank you for watching the video. Bye bye.